Okay, recording has started. And question that was asked about turning in 3, 3, and 3, 4. Yeah, that's due tonight, midnight. I'll go over questions. Yeah, on the 3-point, on any of the spot checks, I'll give you 3 points if you have 75%, at least 75% of it done. But I don't put any comments on the spot check. So yeah, you'll have to get those in class. And all right, let me go to the practice quiz for today. And here's a topic that you might be a bit rusty on. Do problems 1 and 2. And if you had intermediate algebra prior to this class, which is a very common situation, then these kind of problems were one of the main themes in intermediate algebra. And they'll continue to show up throughout this class, so you need to make sure you're up to speed on these. And I give 30 seconds more. And let me just see where we're at over here. Okay. All right, so I have to always make sure I double check I haven't muted my microphone. All right. So find the slope of the line that passes through 2 points. The slope formula is y2 minus y1 over x2 minus x1, where this is the first point. This could be the second point. And so the difference in the y coordinates over the difference in the x coordinates. Like this. Okay, and then find the equation of the line that passes through these 2 points. Now, if number 1 was rusty for you, number 2 might be really rusty for you. But what might help bring it back is a picture. You know the line goes through that point. You know that it also goes through this point. Okay, and we know that every time this moves 1 to the right, it goes down 3. Down to the right, down 3. That will move us from this point down to this point. And the equation of a line in general, simplest form we learned, is this, where the slope goes right here, and the y-intercept, where it hits the y-axis, goes right here, and it's negative 3x plus 4. This is the equation of this line, and we can check our work. If I plug in into this equation 0, 4, plug in 0 for the x, do you get 4 for the y? Yep. If I plug in 2 for the x into this equation, I'd get negative 6 plus 4, which would be negative 2. Yep. These 2 points really would be on that line. Alright, so give me some feedback on 1 and 2. Nailed it? Or still working on it? And if you're still working on it, give me some details. What was the most difficult part for you in this? And type it up, but don't hit enter yet. And go ahead and hit enter. Now let's just look at the feedback. Alright, so I'm also going to have you do something. Let's have everybody go to a window and type in speedtest.net, like I'm doing. Speedtest.net, some open window. And when you hit enter and go to this, if you then go to this go button, it'll test your internet speed. And you got to give it a minute. You're going to get a ping number. We're not going to be interested in that. The number I'm interested for y'all is this download number. And see, it takes a little while to get that. Now it's going to determine an upload number as well. But what's going to be relevant for you is your download number. And if you would all go into the chat and type in your download megabits per second. And let's see what you got there. So you're going to get varying speeds, and if you're down in the single digits, that can really interfere with your you know, like if you're getting a lot of interference, you're getting screen freezing and so on, it might be that your download speed is yeah, see, Beverly's kind of a low, Annika is pretty low. And that could be a cause of some difficulties. And
can you repeat the instructions for the speed map?
okay, you go up at the URL place and just type in speedtest.net, and then hit the go button, and that's all you do. And then it'll conduct the speed test. Okay. And Sienna, you're not seeing stream, even though your internet's pretty good. All right. Go ahead and also type in if you're having difficulties. If you're getting a lot of interference, or Max can't see anything. Max, you had really high. You're not getting anything. Okay, and use your own judgment on any given day. If it's just going to be better to later get in and watch the video, then use that. Keeps going black. Ian, you had pretty fast, and it's still. Sometimes the stream freezes. It's breaking up. All right, well, we'll just have to do the best we can. All right, let's go to numbers 3 and 4. Oh, let me just see what the feedback was on. Okay. So, find the slope of the line that passes through the point 1, 3, and 5, negative 3. That's number 3. And number 4, find the equation of a line that passes through the same 2 points, 1, 3, and 5, negative 5. Okay, let me have you stop with the slope problem. And the slope on this one is the difference in the y-coordinates, the difference in the x. Okay, and then find the equation of the line that passes through those 2 points with that slope. Let me give you just one more time on that. Okay, so let me draw a picture here. If I was over 1 over and 3 up, and if I was 2, 3, 4, 5 over, and 5 down. Now, I can kind of guess what the b is going to be. I know that the m, well, I've already figured it out, it's -2. My b, well, what would it be? The slope is -2, so every time we go 1 to the left, see, if we went 1 to the right, we'd go 2 down. So if I go 1 to the left, I must go 2 up. And we were already at 3, so it must be 5. So notice I could have figured it out this way. So then y equals -2x plus 5. Another way I could have figured it out is we're not confined to just y equals mx plus b. We could have also used y minus y1 equals mx minus x1. This is called the point-slope form. This is called the slope-intercept form. Oh, no. This is called the point-slope form. I have them backwards. Point slope form for the equation of the line, and this is slope intercept form. And it's really easy to remember these names because, oh no, I got them backwards again. Point slope form is this one, and slope intercept form is this. Alright, so now, see, because you have the slope and the y-intercept. And here you have a point, x1, y1, and the slope. Alright, so what I'm going to do is I'm going to plug one of those points, like 1, 3, into here. Y minus 3 is -2, because we know the slope was -2, x minus 1. And then y minus 3 is -2x plus 2, add 3, y equals -2x plus 5. We get exactly the same answer either approach that we use. Alright, give me feedback. on numbers 3 and 4. Type it up, but don't hit enter quite yet. Get all the feedback at the same time. Okay, go ahead and enter your feedback on 3 and 4. Keeping up through OneNote. Very good idea. So,
No.
alright, the OneNote will give you that. You get to see that. That's very good thinking. Okay. Alright, so we're getting a little bit of noise. Sasha and Eve, if you could mute your microphones. Okay, Eve, you can still mute yours. Alright, let's go to number 5. Tuition at Boston College in 1980 was $48 per credit. In 2020, the tuition is way more. Now I made these numbers up though. $652 per credit. On average, how fast is tuition increasing at Boston College? So, I'll give you a minute. So I think that idea of opening up OneNote before class starts each day is probably going to be really important, and so that if your connection gets poor, you still get the visuals of what's going on. And hearing me, which seems to be a lot more reliable than seeing what my screen is showing, and then getting the visuals from OneNote, be a great combination there.
How do we access OneNote?
Okay, so I put an announcement. So go to Canvas and look at, it's one of the very first announcements. And it describes that OneNote is part of the Microsoft Office package. It's just like Microsoft Word and Microsoft Excel, and that you have free access to that being a community college student, and it describes how you can get that for free, and then download the Microsoft Office and use the OneNote. I've heard something about, like, if you already had Microsoft Office and you were using the OneNote, it didn't always work, it didn't always access this, but if you download the community college OneNote, community college Office, and then use the OneNote from there, that will reliably work for you.
Okay, thank you.
You're welcome. Okay, we have 30 more seconds. Alright, so we put the year here and tuition. Here, then in 1980 it was really low, and then in 2020 it was way higher. Now we'll just put it right here, 1980 comma 48. You can think of that as a point in space. And this is 2000, oops. (2020) 652 is the second point in space. And this is a 40-year gap. And this is a gap of how many dollars? 652 minus 48, which is $604. So in 40 years, it went up $604. How much is it going up per year? How fast is the tuition increasing? Alright, so now if it went up like, I don't know, $10 a year, that would be over 40 years, it'd be $400, but it's going up even faster than that. You find it precisely by getting the slope. Slope is the same as average rate of change. It's the slope of this line segment. And it's the difference in the y's. So it's this right here over the difference in the x's. So 604 over 40. And if we put the units, this is dollars, years. And then if we punch this out in my calculator, 604 divided by 40, 15.1, and that's dollars per year. So how many dollars per year tuition is going up over that time period? Alright, give me feedback on number 5. Type that up, but don't hit enter quite yet. Nailed it, or what you're still working on this. Okay, go ahead and hit enter. Alright, and then let's go to number 6. There's functions f, g, and h. F of x is 7 minus x. G of x is 2x minus 1. H of x is 3x minus 4. Find h of g of f of x. It's composition of those functions. Okay, I'm going to do the first step for you here now. It's, we put these all in exactly the same order, and you put one inside the other. We call this nesting. plus the parentheses. And then you keep going. I'll give you one more time. Okay, 30 seconds more. All right, we've got to do the innermost one first. I know that f of x is 7 minus x. Just replace it. Like this. And then I'm still going to do the innermost one. G of anything is 2 times that thing plus 1. And 7 minus x is going to go in here and in here. So it's going to be G. Now I can write that in here, or I can do what we call a little timeout. I'm going to do timeout like this. I'm going to figure out what just this inner part is. And it's 2 times 7 minus x plus 1. And then distribute the 2. It's 14 minus 2x plus 1. 14 and 1 add together. That's 15 minus 2x. So this is just this portion of this right here. This portion becomes 15 minus 2x. And then we're skipping over this timeout part. H of anything. Well, h of anything really means 3 times that thing minus 4. So I'm going to put 3 times 15 minus 2x minus 4. Distribute the 3, I get 45 minus 6x minus 4. 45 minus 4 is 41. 41 minus 6x. Thus, h of g of f of x is equal to 41 minus 6x. That's my answer. Alright, tell me how you did on number 6. Type up some feedback, but don't hit enter quite yet. Okay, go ahead and enter. And let's go to the next one, number 7. F of x is the square root of 2x minus 3. Find two functions, g of x and h of x. So that f of x is h of g of x. I'll give you a minute on this. Okay, 30 seconds more. Okay, I want to point out that this is the function g of x that's got to happen first. So we'll figure out what g of x is. G of x equals, so if I told you x is 1, would you take the square root first? No, you'd multiply 1 by 2 and then subtract 3. So you would do this first. And then h of x is the thing that happens after that, which is take the square root of whatever is the input of h. And this combination would work. And if I check, it would be h of g of x would be h of 2x minus 3. H of anything is the square root of that thing. And that works. Alright, now, this isn't the only possible solution. There's actually an infinite number of solutions. Let me show you just one other possibility. You could do g of x equals 2x. H of x, now this is a little tricky to think about it, but 2x would be the input for the h of x. So it would be the square root of whatever the input was minus 3. And then the check here could be like this, h of g of x is h of 2x. And when you put 2x in for the input, it's square root of 2x minus 3. It works. It checks out. Alright, feedback on number 7. Type that in. Don't hit enter quite yet.
No me peló el maestro.
Open there.
No me dijo.
Okay. Alright, go ahead and hit enter on your feedback. Alright, sometimes coming in and out. Alright. And alright, number 8. Same problems we did in the previous practice quiz. Draw a quick sketch of the following curves. Plug in points in XY table only if you need to. Can you draw a quick sketch of y equals x squared and y equals absolute value of x? Okay, 30 seconds more. Alright, y equals x squared. That's a parabola. And we want to emphasize this vertex of the parabola is on an upward parabola, when both wings go up, it's the lowest point. On a downward parabola, if the parabola had been going like this, the vertex is then the highest point. And then right on both sides of the vertex, we say the graph is symmetric. It looks identical on both sides. Alright. the absolute value of x. That graph looks like. Straight line, but when you get to the left of it, you also get positive results. It's this V. And then y equals square root of x. And now square root of x is one that we did. I think it was on Tuesday. And then y equals 2 to the x. You haven't seen before. And so that, it's something new. See if you can get a rough sketch of y equals 2 to the x. Okay, 30 seconds more. All right, so the negative values for x can't be inputs. You can't take square roots of negative numbers. You take square root of 0 and you get 0. Square root of 1 and you get 1. Square root of 4 you get 2. Square root of 9 you get 3. This grows very slowly. Like this. And it's actually the upper half of a sideways parabola. And then y equals 2 to the x. We'll be getting to this kind of function later on. I just want to show you quick. And if x was 1, you'd get 2 to the first. If x is 2, you get 2 squared. 3, you get 2 cubed. Keep getting different powers. So what happens is when x is 1, you get 2. When x is 2, you get 4. 3, you get 8. It goes up very steeply. And you might think that this graph is going to look much like this, because it kind of looks similar. Turns out this one is a lot steeper than that one. And it has another difference. It's going to wind up not going back up over on the left. On the left, it will go like this. We'll get into this in a later section. We'll spend quite a bit of time with graphs like that. But I just wanted to show it to you one time so that when we see it later, you can have a reference, point of reference. Oh yeah, we did something like that. All right. So on C and D, give me a little feedback on those two. Don't hit enter quite yet. And go ahead and hit enter. feedback. Alright, now last one. Solve x squared minus 5x equals negative 4. Okay, 30 seconds more. Okay, this is what we call a quadratic equation. And quadratic equations we solve by A, factoring, or B, quadratic formula. Mentioned this earlier. And in either case, we set equal to 0. So the first step plus 4 is 0. Now, I try to factor it. If it factors quickly, great. If it doesn't factor quickly, I jump to the quadratic formula. And x times x will give me the x squared. And then determine the signs next. Two things have to multiply to be positive 4. They either have to be both negative or both positive. If they're both positive, we wouldn't get this negative middle term, so they have to be both negative. And then two things that multiply to be 4. And when I add them, I get 5 is going to be 4 and 1. And it could be in either order. It could be 1 over here and 4 over here. And now I can just look at this and tell what my answer is. What number will cause x minus 4 to become 0? Because two numbers will multiply to be 0 only if one of them is 0. And if x is equal to 4, or what will cause this to be 0 if x is equal to 1. And I can check my work. I can go back to the beginning. If I plug in 4, I get 4 squared minus 5 times 4, which is 16 minus 20, which does give me negative 4. And if I plug in 1, I get 1 squared minus 5 times 1, which is 1 minus 5, which is negative 4, which is what it was supposed to be. So those are my two answers. Hold feedback on number 9, and then we're going to take a break. So type up your feedback. Don't hit enter quite yet. Okay, go ahead and hit enter. Yes. I'll check my personal chat during the break. We can talk during the break with the microphone, or we can talk via the chat. Okay. All right. We will start again. Space here. At 1:39. Okay. Okay, and Beverly, we can can you tell me how things are going, Beverly? Anybody else need to speak with me at all? Okay. Okay. Okay, I hear you, Beverly. Well, I see what you're typing. Yeah. Sorry about that. It's not even allowing you to use your microphone. Okay, I'll answer questions on 3.3 and 3.4 today. Anything else I can do for you now? You know, if you're having troubles on an individual section, you can ask me for an extension on the time, and I can grant that, and I'd be happy to give you that. You know, like if you want over the weekend to do the 3.3 and the 3.4, I could grant you that. So you get that to me on Monday. And I don't give feedback on the spot check stuff. I don't rate any particular problems. I just put a 3 if you've gotten it correct. the feedback really is coming from, during class when people can ask questions. Yes, I'll do that on not on the spot check, unless the spot check is the only thing you turned in. But if you turn in something for the spot check, like on 3.2, you gave me a spot check 3.2, and then you gave me the final homework 3.2. The final homework 3.2, I'll say redo this and this. But generally on the spot check, no, you just would get a 3 for having done the 3, for having done at least 75%. Okay, I'll see you back in class at 1:39. All right, we'll get back to work and questions on homework. So could be 3-3, 3-4. We also had a worksheet on composition of functions. You can speak in your question or you can type it in the general chat. Questions on homework. Yes.
I was
So Sasha, I'm getting so much feedback when you're trying to talk. You probably have to type it in on the general chat. And if you've got a headphone, you could plug in your headphone and then talk, and that'll probably eliminate your feedback. For some reason, it's like you're registered in twice, and it might be part of the problem why you're getting this feedback. Okay, so Sasha, number 3 on what section, or was that on the handout, on the worksheet? Number 3 on the handout. All right, so here's the handout. Okay. Soon after class last time, I noticed that there was an older version of the handout up that had a number 3, and I took that off and I put up the new version of the handout, and there is no number 3 in the new version of the handout. So you don't have to do that problem, number 3 in the handout. You must have grabbed that handout probably just before I uploaded the new one. So any of you who did the same thing, there's no number 3 on the new version of the handout. Okay. All right, anything else? For the graph, do we do a table? Is this on the handout again, Sasha? So create a function, I don't think you have to do a table. No. I would say you do not have to do a table. Parts D and E of question 11 and 3.4. Okay. Question 11, no, this is 3.4. Question 11, 11D and E. Let's look at those. So part D. G, composition G of X. G of X. Do the inner one first. It feels strange when it's the same letter, but you just do one at a time. inner one is 3x minus 5. Now you do g of that. Now when you do this outer one, we have to think of g in the more general sense of it's g of anything is 3 times that thing. So you're plugging in g into itself. And then we're going to simplify this. So that's what I'd finally get right here. And do you want me to do f as well? Or does that answer your question, Ava? I mean E. Did you want me to do part E as well? So I think it's pretty much the same idea. Plugging something into itself. Okay, anything else? Just confused about the symbol. Go ahead and clarify, Eva. You can't see the stream. Oh, shoot. Okay. And all right, is there any other questions? The symbol between G and F. How do I work it? On the circle. Oh, the little circle. You just replace, that's called decomposition. This little circle. Composition. And you replace it by just writing them in exactly the same order. Like if it was F composition G of X. Keep everything in the same order. You just put one inside the other, like this. Alright. So, let's go on to 3.5, transformations of functions. And problem number 1 is to graph y equals x squared. Well, we already did this, but do it with a little more detail by filling in this table first, transferring your points over to this graph on the side, and then do it again over here. And if you were in intermediate algebra, you had done a similar task. We're going to do this very quickly here, but I just want to point out some basics about transformations of graphs. So I want you to do numbers 1 and 2 and put them both on this same graph over here. So I'm going to give you a minute to do that. So this first one, when you square all these, 0 squared is 0, you get 1, you get 4, 1, 4. When you graph these, 0, 0, 0, 1, 1, 2, 4. So we get this parabola. And then, let me give you a quick little bit of time to do number 2, if you haven't already gotten there. Okay, and what we get is the same answers. Because when you square something, you get this one squared, this one squared, these squared, but then you get the plus 3 to everything. Now, the 3, what it does is it moves the height up. This one had a height of 4, but it got moved up 3 units. Let me make this a little bit larger here. Each one of these points moves up 1, 2, 3 spots. So whatever the spot was, this point, 1, 2, 3, every single height got shifted up 3 units. And the new graph is this. And we call this a vertical shift. And this is a classic transformation of a graph. When you put a plus 3 at the end, it just takes that shape and moves every single point up 3 units. Okay. Let's go to number 3 and 4. Number 3. Let's graph this one on this graph on the right. Now notice, when it asks you to graph this, it already picked a middle point. The middle point for the x table over here was 0, to make sure you didn't do just the right half of this parabola, but that you picked some negatives and positives and you got the left and the right half. To do it this time, we also need to go, but it's not negatives and positives. What's more important now is being on both sides, because negative 3 causes this to be 0. So we want things like negative 2 and negative 1 to get larger, but also smaller. And go ahead and see what happens when you get these outputs and graph them over here on the right. Okay, so when we do this, so let me take negative 2 plus 3 is 1. 1 squared is 1. Negative 1 plus 3 is 2. 2 squared is 4. Negative 4 plus 3 is negative 1 squared is 1. Negative 5 plus 3 is negative 2. Negative 2 squared is 4. So if I graph all these points, zoom in a little bit. Negative 3, 0. negative 2, 1, negative 4, 1, negative 5, 4, and negative 1, 4, negative 1, 4 should be over here. Okay, so this okay. Now, what's happening here? It's the same parabola that we had up here, the blue parabola, except it got moved 3 units to the left. Now, notice from f of x equals x squared to here that the x is replaced with x plus 3. So there was no replacing of the x up here. This plus 3 was tacked on to the end. When you replace the x with x plus 3, you had to put it in parentheses like this. X is replaced with x plus 3. This is called a horizontal shift. And horizontal shifts, they move in the direction, opposite direction of the sign. So, the normal horizontal positive direction is to the right, but we move opposite to the left 3 units when we replace x with x plus 3. So, how do you tell a vertical shift from a horizontal shift? Horizontal shift is a replacement. The x is replaced. That's why horizontal shifts are usually in parentheses. And when you're doing horizontal shifts, you have to remember to go opposite direction of the sign. And then let's graph y equals 3x squared on the same graph. If I make a table for this, I can put 0 in the middle. Let me give you a brief minute to fill out this table and to graph that. So this would be 3 times 0 squared, which is 0. 3 times 1 squared, which is 3. 3 times 2 squared, 4 times 3 is 12. 3 times negative 1 squared. Negative 1 squared is positive 1 times 3 is 3. Negative 2 squared is 4 times 3 is 12. So if I was to graph this, 0, 0, 1 over 3 up, negative 1 over 3 up, and then 2 over 12, 2, 3, 4, 5, 6, 7, 8, 9, 10, to go a little higher, 11, 12. And so if I go 2 over, I'm all the way up to here. And 2 to the left, I'd be all the way up to here. Has a hard time making dots. So this is also a parabola. But way skinnier parabola. Alright, we call this a vertical stretch. As if, imagine this parabola. Let's look at y equals x squared, the blue parabola. Imagine it having rubber bands that go from each of these points on the parabola straight down to the x-axis. And all these rubber bands are just a little bit of tension holding it in place. And when we stretch it vertically, we grab this blue curve all at once and lift it upwards. And all the rubber bands stretch, in this case, to be 3 times as tight as they were before. And we go up 3 times as far. So y equals x squared becomes really skinny, like this. Vertical stretch. The number in front that you multiply by causes the vertical stretch. And if that number was 1, then y equals x squared stays the same. If it's bigger than 1, then we're stretching it upwards. If it's smaller than 1, like 1/2 or 1/4 or something, we'd be pushing the graph of y equals x squared downward toward the x-axis. Alright, let's go to number 4. Let's graph this one, fill in that table, and then transfer it over to a graph. And then also do number 5. You can put it on the same graph. And by the time you get to number 5, you might be able to get the answer without making a table. Just saying, oh, I know what's going to happen. See if you can get number 5 that way. Okay, so on these, so if we put negative of 2 squared, it's only one negative sign, so it's negative 4. Negative 1 squared is negative 1. Negative 0 squared, well 0 can't be positive or negative, so it's 0. These we have to put in parentheses. That negative sign is the negative out front, and the negative 1 squared. Now, that's the same as negative 1, because negative 1 squared is positive 1, you still have that extra negative. The negative in parentheses, the negative 2 squared is positive 4, but then you take an extra negative. You get this. So if we take all these points and transfer them over, we are going to get 0, 0, negative 1, negative 1, positive 1, negative 1, positive 2, negative 4, negative 2. -4. And then if I connect them with a graph, I get this. So this has a name. We call it a reflection. Across the x-axis. So you get the original y equals x squared is reflected across the x-axis as if you had folded your paper along the x-axis with wet ink, and then the new image shows up below the x-axis. Okay, and now let's go to number 5. If we graph this on this graph, all right, we're going to just identify what the different parts do. 4, the +4 and the -5 are going to have different effects. This, when you just tag it on the outside, is a vertical shift, and it makes it go in the same direction as the sign, up 4. This one, you're replacing the normal x with f of x equals x squared. So we compare it to f of x equal x squared. When we compare this one, the x here has been replaced with x minus 5. That causes a horizontal shift. Now the horizontal positive direction is to the right, negative direction to the left, but for transformations it gets reversed in here. We go the opposite direction of the sign, so we go right 5 units. So I'm going to take this blue curve and I can shift it all by just shifting the one key point, the vertex. That's the bottom point of the parabola. I'm going to go right 5 and then up 4 and I'll land right here, and then it's the same shape that we had before, still a parabola, but its vertex is now 5 over 4 up. Okay, so hopefully this is stuff that you remember a bit from intermediate algebra. Okay, so now we're going to go to number 6. A cell phone plan costs $10 per month plus $3 per hour. X is the hours used in a month, and Y is the cost. Write the function equation and then graph it. So I want you to work this one on your own, but also go to your group chat, and when you get the function equation, type it in, but don't hit enter quite yet. So let me give you a minute on this. We'll do the graph of it together, but for writing the function equation, see what you can get on your own. Okay, go ahead and hit enter. And see what others in your group have gotten. Talk it out briefly. All right. Group 1. Do you have an answer for this? Anybody?
I think that most of our screens. We can't really.
You can't see it?
We can't.
Okay.
Can't. Anyways, I don't think they're either.
Okay. Let me put this in then. All right. So the function equation. Notice that this happens once. It costs in a month. This cost happened once. And this is as many times as the hours used. So this cell phone plan would be, most of us have unlimited time, probably, or something pretty close to that, because we're on our phones a whole lot. But suppose you had somebody like my mother who almost never used her cell phone. Instead of paying a whole bunch per month, she might like something like this. So the cost is $10. So hours used in a month, the cost for the month would be just $10 plus 3. But how many 3s are there? Well, as many hours. If you used your cell phone for 2 hours, you'd get that $3 charge twice. So it would be 3 times x, like this. Now, we can also write it as y equals 10x plus 3. And this, when I graph it, this has a y-intercept of 3, so this point, and then a slope of 10. So it would rise 10 and run 1. It's going to be very steep. Now, it doesn't make sense to draw this to the left, because you can't use negative number of hours. $10 per month plus $3. Ooh, when I rewrote this, I wrote it backwards. Sorry. $3x plus 10, and then I screwed up with this graph. Alright, let's come back to here. 3x plus 10. So 10 is the y-intercept. And then it's going up 3 over 1, and it goes like this. Okay. And we have just gotten out of time, and this is going to be some kind of practical applications. We'll get to this at a later time, but we got the essence, the essential things for the transformations done. So the homework is 3.5, and we will stop here, and I'm we'll see you all next week on Tuesday. Any questions? Okay.